Hello and welcome to our new unit on triangles. First section is going to be classifying triangles and triangle angles. Go ahead and grab this, pause the video as needed, and go ahead and get the title down for the specific header. So classifying triangles and triangle angles. We could classify triangles by their sides, and we could classify triangles by their angle measures. We're going to do both here, and we're going to pretty much be creating two columns. So the first one is going to be classify by sides. Okay, do a little underline. And the first one we're going to be talking about is scalene. Now, these are terms you hopefully have seen before, but if not, no worries. A scalene triangle is a triangle with no sides congruent. Simply put, none of the sides are congruent. So what we'll have here is, if we'll draw a triangle really quick, I'm going to put one tick here, indicating that it has one specific length, two ticks here, showing that it's not congruent to the first side that I ticked, and three ticks here showing that it's not congruent to any of the other two sides that I ticked. So that is a scalene triangle. Now it could be, obviously, it could be any number, it could be any length, like 9, 10, 11. It does not have to be bigger or smaller. This could be 6 if we really, really wanted it to be. The 3 ticks does not have to be the biggest one. Okay, so that's scalene. Then that's no sides. Well, what are the other options? Well, what if 2 out of the 3 sides are congruent? And that's where isosceles kicks in. Isosceles triangles are triangles with 2 sides that are congruent. And we'll go ahead and draw one. And I probably should specify this. I'll put this in red, at least. Okay, so here we're going to draw one tick, and then 2 ticks to show that there are congruencies. And to be even more specific, when you have an isosceles triangle, base angles are congruent. So typically we would call this top angle the vertex. And I'm going to put 2 tick markers because it's across the one from the 2 tick side. We'll call this the vertex. And then we'll put 1 tick here because they're directly across the 1 tick markers. You'll see what I mean by that in the next lesson. And we'll call these two the base angles. Okay, anytime we have an isosceles triangle, we have a vertex and we have base angles, and the base angles are congruent. These are the angles directly across the congruent sides. Okay, so that is important to know. Now, the third triangle that we do need to know that's classified by its sides is, when you have 2 sides that are congruent, why not go a third? And that's your equilateral. An equilateral triangle. Equilateral triangle is it's a triangle with all sides congruent. So it's all 3 sides. So if you want to put the 3 there, you can. Let's go ahead and draw one. Okay. Let's make this a little more equilateral. 1 tick, 1 tick, 1 tick. Okay. Now, those are the 3 triangles based off of their side measures. Well, what about angles? So we could classify also by angles. I'm going to do a little bit of a divider here. Actually, no, I'm not going to do divider. Let's just go ahead and start doing it. Classify by angle measures. Okay, and let's go ahead and underline this one. And let's start classifying. First one is acute. As we know what an acute angle is, and it's an angle whose measure is less than 90, and that follows here. In this particular case, all angles are less than, get rid of this, we don't need that anymore, less than 90 degrees. You're going to see this become a constant theme, the 90-degree marker, okay? Now, we could obviously draw an acute triangle. In other words, the largest angle is less than 90. That's another way to think about it, okay? Now, obtuse is, well, let's actually go right first because right is the next in order in terms of acute. If we are less than 90, we have a right triangle. And a right triangle is a triangle that has one angle that is equal to 90 degrees. Okay? And we show this by, well, how do we show right angles? A square. We need to show a square here, and that will be the largest angle in this because, well, you'll see what I mean by the triangle, the angle sum theorem. Okay? We also have, well, after acute is less than 90, right angle is exactly 90, an obtuse angle, or obtuse triangle, let's just do obtuse. It is a triangle with one angle that is greater than 90. Greater than 90. So you see that theme again. 90 degrees is kind of the pivoting point for these triangles. And let's go ahead and draw an obtuse triangle. And we could do it by eye. And this is not, there you go. We could clearly see one angle is greater than 90 degrees. And we have that obtuse angle. And last but not least, I'm going to purposely draw this one next to the equilateral triangle. And this one is called equiangular. Equiangular. An equiangular triangle is a triangle where all angles are equal. In other words, they're all 60 degrees. Because you're going to find out in a second, in a triangle, there's only 180 degrees, okay? So if there's 180 degrees to split in a triangle and all of them are equal to each other, that means you take that 180, you divide it by 3, and each of them would have to be 60 degrees. Because all of them are equal. Thus, equiangular. Just like how equilateral also starts with the equi prefix. Equilateral means the lateral sides are all equal. Okay? Equiangular is all the angles are equal. So these two are always related to each other. Anytime you have an equilateral triangle, you also have an equiangular triangle. Okay? Now, there's a second component to this, and like I said, we were going to talk about this, the triangle angle sum theorem. So this is the first of two theorems we're going to talk about today. So I'm going to draw a dividing line because this is kind of like a split lesson. So the triangle angle sum theorem. And this states that all angles in a triangle add up to 180 degrees. Okay, so for instance, if I drew a triangle here, let's extend this out a little bit so I have a little more visual. Call this angle 1, 2, and 3. We could then say angle 1 plus angle 2 plus angle 3 is going to be equal to 180 degrees every single time. Okay, now we also have what we call exterior angles. Okay, so we should define what an exterior angle is. Well, exterior angle is an angle on the exterior of a triangle. So this is the angle formed by extending a side, any side, of a triangle past the vertex. And what I mean by that is this. Okay, I'm going to draw another triangle. If, for instance, I extended this triangle past the vertex, the side anyway, past the vertex, here we have an interior angle. And then when you extend it, this is an exterior angle. Okay, so there's your vertex here. And then we have that exterior angle. Okay, and what's nice about interior angles and exterior angles, if we wanted to, we could also extend some other pieces. For instance, if I wanted to extend this one, then we would have an interior angle and then an exterior angle. So you could do it on any side of the triangle. But what's nice about this is that it creates a linear pair. Right? Interior angles and exterior angles are a linear pair. So if you want to make a note of that, that's perfectly fine. Hopefully it's obvious just because of the drawing. But exterior angles and interior angles add up to 180. Okay? And that leads us to the interior or the exterior angle sum theorem. So the exterior angle sum theorem, or the exterior angle theorem, I should say, angle theorem states that the exterior angle of a triangle is equal to the sum of the two non-adjacent angles. This should probably be one word. Non-adjacent angles. So what does this mean? Well, if I took this exact same diagram, and I'm going to just redraw it just to create a different visual. If I took this triangle, extended this side past the vertex, and I, for instance, said that we had one angle here that was 70 degrees. Okay, well that means this angle here has to be the supplement to it, and 180 minus 70 is equal to 110. Well, if you also think of a triangle, 180 degrees are in a triangle, and we know that, for instance, if we had the two non-adjacent angles here, non-adjacent angle 1, non-adjacent angle number 2, these are your non-adjacent angles, then we know that these two should add up to 180 minus 70 as well. In other words, there should be 110 degrees between these two, okay? Because in order for the triangle angle sum theorem to work, all the angles have to add up to 180. And if we already have 70 from this red one, then these two angles, let's call this 1 and 2, angle 1 plus angle 2 has to be equal to 110 because that is what is remaining once you take out this 70. Okay? So what it is saying is these two non-adjacent angles will always be equal to, the exterior angle. Okay? That's it. So there's all of what we need to know to start off our unit, classifying triangles by their sides, by their angle measures, and then the triangle angle sum theorem shows up a ton. All angles should add up to 180 degrees, and then some other minor definitions. If you do have any questions, please let me know, and I will see you in the next one. Bye.